Here's a strategy for solving equations that I've used for many years, and it's very helpful. The first thing you should do is go ahead and eliminate any fractions by cross-canceling with the LCD. You'll recognize that abbreviation as the least common denominator. I'll demonstrate this later. The second thing is you go ahead and eliminate parentheses using the distributive property. Now, the distributive property, as you recall, is when you multiply the number in front of a parentheses by every term inside of the parentheses. The third thing to do, just to make it more efficient, would be combine like terms that are on the same side of an equation. Then you can move terms left or right by adding or subtracting. That will isolate the variable, which is the letter. And only last should you divide each side by the coefficient of x. That is the number in front of x. Now, when you do this procedure of solving, three things could happen to you. Thing one, you could get a single solution or an answer. If that happens, then you have a conditional equation. Thing two is you could get a solution in which every number in the world works, all real numbers. That's called an identity. And thing three is you could get a no solution. No answer in the world works, and that is normally demonstrated with this symbol of the zero and the line through it. That's called an inconsistent equation. Now, here are some examples that just involve one step. If you notice in the first equation, if I were to move over the negative 17, it changes signs. When you move terms side to side with addition or subtraction, you use the opposite sign. That would leave the x on the left, bring down the equals, and 6 plus 17 would be 23. That's what we call the solution or the answer. Now, in the second example, you'll notice it has a fraction. And I said that you could eliminate fractions if you cross-cancel with the LCD. The LCD common denominator here is 6. So I will put a parentheses and a 6 beside both terms on both sides of the equation. Now, since this is a different process from moving a term, you do not change the sign. Use the positive 6. Now, if you recall, 6 is a whole number, 6 over 1. Now you can see the 6 at the top and the 6 at the bottom, which cross-cancel. That will leave 1 times x, which is x, and 3 times 6, which is 18. That's the solution. And in this third example, you have to get rid of the 4. You always will eliminate the coefficient by dividing by that number in front of x. When I divide, you'll notice I put a fraction bar that symbolizes division, and it leaves us x equals 5 as the solution. Now, here are examples of multi-step equations. If given the first one, I would move the 14 over first to make it be positive 14. That will leave 5x equals a negative 75. Then I would divide by 5. Always divide as your last step. And when you divide that, remember your sign rules. So x is equal to negative 15. In this other equation, I would need to eliminate the parentheses. So I multiply using the distributive property to get 10x minus 35. Do not multiply that minus 2, just bring that down. Then multiply on the other side of the equals to get 5x minus 20, and then bring down the 8. Next, you would need to combine the like terms that are on the same side. So I have negative 35 minus 2, which is negative 37. And I have negative 20 plus 8, which is negative 12. Now and only now would it be most efficient to start moving terms. If I move the negative 37 across the equals, it becomes a positive, leaving 10x equals 5x, and I combine those two numbers to get 25. Then I will move that 5x across the equal, and it becomes a negative 5x. 10 minus 5 would give me 5x equals 25, and then I divide both sides by 5. The solution here is x equals 5. You can always check an answer by plugging it back into the original problem. Now here are some other examples of what could happen. In this first problem on the page, if I use a distributive property, notice that I get 4x plus 24 over on the right-hand side. Now when I go to move terms, for instance, that negative 5 comes over to be positive. I have 4x equals 4x plus 29. And I move that 4x and it becomes a minus. So 4 minus 4 is 0x, which is just 0, equals 29. This is false. Notice the x terms canceled out and it left you with a false statement. If you're left with something false that cannot be true, then this is no solution. It is inconsistent. On this second example, if I use a distributive property to eliminate those parentheses, I bring down the other terms, and then I combine my like terms that are on the same side to make it a little easier. 11 minus 3 would give me 8x. Positive 5 and positive 1 would be positive 6. Now if you notice, 8x plus 6 is on both sides of the equation. Right there, you could stop and say that the answer would be all real numbers. This is called an identity, as I said before. That's because the terms are identical. But what if we kept going? Well, if I move the positive 6 over, it becomes minus 6. And that's just cancels in 0. If I move the 8x back over, it becomes a negative or a minus 8, leaving 0 equals 0. So again, the x terms cancel out, but you fundamentally have a true statement. 0 is equal to 0. That means the answer is all real numbers also.